Okay, so let's get started. So the first thing we're going to start off with is vocabulary. Hello, Chantal. So we're going to speak about vocabulary, okay? Before we start off with the first law, which is multiplying exponents, we first need to know the vocab so that we use the correct words. All right, first things first, exponent. That is the little number there at the top over there. In this case, it's the 2, okay? We have my base, which is the 7. That is my big number. And the whole thing is called a power. Does anybody know what this exponent tells you? Right now, I have 7 to the power of 2. That's how we say it. 7 to the power of 2. Okay, what does this tell me? If I say 7 to the power of 2, or 7 squared, if you want to say it in another way, 7 to the power of 2, otherwise known as 7 squared, means what? Does anyone know? Thank you. It means 7 times 7. So the exponent tells you how many times you are multiplying the base with itself. Nice, Minnie. I love that definition. Okay, how many times do we multiply the base with itself? And that is true as well, blessing. So now that we've gotten that out the way, let's look at the law that we're looking at today. So this law says when we multiply two powers, so remember the power is the whole expression. When you multiply two powers with the same base, I am going to highlight this, okay, with the same base. They have to have the same base. Then we can add the exponents. Okay, this is my example over here. So I have a base of a in both expressions, okay? If there's nothing in between there, it is a multiply. Sometimes there is a dot there, but it is a multiply. So a to the power of m times a to the power of n is the same as a. So you keep the base and you add your exponents, okay? So that's what we're going to be doing today. But my first task for us today is to be able to identify all the different components of exponents, which we just went through just now. So I'm going to do this because it looks a little bit small to me. Okay, that was a little bit of overkill. Make it a little smaller. Do like so. Like so. And move it there. Okay. So we've been given the power, and in the first one, the power is 2 to the power of 3. Remember, power means the whole expression, right? So 2 to the power of 3, what is my base for this power? For the first power, what would you guys say is the base? What would we say is the base? Thank you, Mene. The base is 2. Okay. My exponent, 3. And what is the value? So I want you guys to go 2 times 2 times 2. And my value is, thanks, Logan, that is 8. Right, we're off to a great start. Let's move on. Next one, 4 to the power of 2, my base. 4, nice. My exponent. Nice, thanks, Logan, and welcome. My exponent is 2. And the value is 16. Thank you, Fanny. Next one is 5 to the power of 6, my base. My base is 5. My exponent, 6. And the value of this whole power is 15,625. That is true. Next one, my base. My base is 3. My exponent, 0. And the value, 1. That is one of the other rules of exponents that we'll get to in another lesson. And for my last one, my base, 2 exponent -1 and the value. What is the value for this one? Nice, Buhlali, it is a half. That is another law of exponents that we will get to. Okay, I'm going to leave this here for a few seconds for you guys to screenshot. Okay, basically, I just wanted us to get the hang of my vocabulary. So the whole thing is called the power. The base is my big number at the bottom, and my exponent is a small number at the top. Then the value just means work it out. Nice. Now we have 2 multiple choice questions here that we have to decide what the answer is. Okay, so the first one says, which of the following equals -19 to the power of -12 times -19 to the power of 4? So I'm going to rewrite it on the side here. So it's -19 to the power of -12 times -19 to the power of 4. So what are we supposed to do to the exponents? We are multiplying and we have the same base. Okay, first thing you need to check is that you have the same base, which we do. They're both -19, right? So what do we do when we have the same base and we are multiplying? Law number 1 says we add what? That's true, Buhlale, but what do we add? We add the exponents. Beautiful. So then it's going to be -19 equals to the power of -12 plus 4. So what is -12 plus 4? My final answer has to be -8. So then my correct option is number what? The correct one is option number 1. Beautiful. So the correct one is option number 1. Okay. Nice. Now we have one that's a little bit more interesting here. Okay, you can do it. So let's not freak out here. So we have find x, the value of x, if -4.5 to the power of x times -4.5 to the power of 9 equals -4.5 to the power of 11. Okay. Now, I'm going to start with the left-hand side. We have the same basis of -4, 5, and once again, we are multiplying. So what do we do to the exponents? Times -4.5. Thank you. We're going to add them to the power of 9. Okay. So that is true. That is indeed the answer, Ronnie. X plus 9. So if the answer is -4.5 to the power of x plus 9, then x has to equal how much, guys? X has to equal 2 because we said we want this to be equal to -4.5 to the power of 11. Well, that means if this whole expression has to equal 11, that means x has to be 2. Nice. I'm going to leave this for a few seconds for you guys to screenshot. If there's anyone that I have lost along the way, now is the time to tell me. I'm just going to close my door quickly while you guys screenshot. There's a lot of noise outside. Send your questions, and then when I come back just now, I'm going to answer all the questions from the chat. Okay, I don't see any questions, which means everyone is with me and understands everything so far. Right, let's move on. Now we have to work them out ourselves, right? We have to work them out. And if we can find an answer, I want us to simplify. Okay, so I'm going to number these. I'm going to number these so that if someone has a question, they can say, ma'am, for number A, what? Okay, so this is A. Okay, so we have 23 to the power of 2n times 23 to the power of 6n. What are we doing to the exponents again? We are multiplying. Do we have the same base? Yes, we do. So we do what to the exponents? Add. So I have 23 to the power of 2n plus 6n. Can we simplify that answer? Is it possible to simplify that answer? We have 23 to the power of 2n plus 6n. Nice, Mene. We can simplify it because they are like terms. So then it will be 23 to the power of, I was about to write 2n again, to the power of 8n. All right, here's our next one. Next one's over here. We have negative 3 to the power of negative 49 times negative 3 to the power of 95. Okay, let's see. This is B. So we have negative 3 to the power of negative 49 plus 95. And my answer will be what? Negative 3 to the power of 46. Do you guys think this answer will be positive or negative? Let me see what we think. Do you guys think this answer will be positive? How do you know that it will be positive? How do we know that my answer is going to be positive? Ooh, that's something to think about. It's a nice challenger. Negative and positive make negative. But remember, Mine, we are not multiplying the base with the exponent. Okay? This exponent is telling us how many times we're going to multiply the base by itself. So we're going to have 46 negative 3's multiplied by each other. Oh, Botlal is onto something. A negative and a negative makes a positive. Remember, guys, if it's an even number, that means all the negative will have a partner. And as Botlal said, a negative and a negative will always give you a positive. So this answer will indeed be positive. That was something to think about. Okay, now we have a next one here. Negative 22 to the power of x plus 7 times negative 22 to the power of 7. All right, this is number C. Let's see, negative 22 to the power of x plus 7 times negative 22 to the power of 7. I have no idea why I rewrote it, but we have to add the exponents. So this will give us negative 22 to the power of x plus 7 plus 7. Can we simplify this? Is it possible to simplify this exponent? Yes. Okay, let's simplify it. Let's see what the answer will be. It will then be negative 22 to the power of what? Ooh, 14x. Do we all agree? There are 22 of us in here, so let's hear what everyone else says. Do we all agree that my answer will be 14x? Let's think about it carefully. Sandy also says 14x. Everyone else, what do we think? Okay, I see a thumbs up, so we agree. Oh, Wutlali came through with a different answer. x plus 14, Blessing says 14x. Okay, which ones are the like terms here? Let's highlight like terms. We have an x, and we have a what? Which other ones are like terms? X is a like term on its own, right? We can't do anything about x, it's on its own. We have an x, and we have 2 7s. Thank you, Butlale. Are we allowed to add this x with the 7s? No. And we were not multiplying in the first place. So are we allowed to introduce a multiplication symbol? No. So my answer will then be x. And then if you add my like terms, which is the 7 and the 7, it will be plus 14. Do we get it, guys? Are we with me? Yes, Minnie says yes. Wonderful. So remember, you cannot introduce something that wasn't there in the first place. Okay, we have to stick with the question and how it was and solve it as it was. I'm going to do another one that looks like this one just now. Let's just first do this one. 8 to the power of negative 14 times 8 to the power of negative 4. So as we know, this is number D. It's going to be 8 to the power of negative 14 plus minus 4. What's happening to this plus minus in the middle here? That plus minus will become a negative. Thank you. So it becomes 8 to the power of negative 14 minus 4. So then my final answer is 8 to the power of what? My final answer is 8 to the power of negative 18. Nice. We must go revise our integers. Okay. Okay, I want another one that looks like the one we did over there. I'll zoom out just now and then everyone can take a screenshot. Don't worry. Okay. I believe we ended at D, so I'm going to create a number E here. And I'm going to say 7 to the power of 2 plus x times 7 to the power of x minus 1. Right, so we're adding exponents once again because we are multiplying. So I'm going to say 7 to the power of 2 plus x minus 1. Do we have like terms here? Do we have like terms? Yes, what are my like terms? Okay, x and x as well as what? Two and negative 1. That is a very dark color, but I'm hoping you guys can see still. Okay, so then it'll be 7 to the power of, what's x plus x? X plus x. X to the power of 2. Oh, let's see what's happening here. What's x plus x, guys? Let's think carefully. 2x. It's not x to the power of 2. Okay, so it's 2x and then 2 minus 1. 2 minus 1 is plus 1. All right. Okay, before we do our brain break, let me first zoom out so you can take your screenshots. There we go. And while we're taking our screenshots, thumbs up, thumbs down. So far, is everyone with me? Are we all good? If you don't understand anything, give me a thumbs down. Go to reactions if you are new. You go to reactions and you give me a thumbs up or a thumbs down. Okay, I see thumbs up from most of us, not all of us, but most of us. Okay. Wonderful, wonderful. Okay, hoping we are all done screenshotting and writing. I'm going to skip this. I'm going to go right to our challenging ones. Okay, so what's happening here? In the first one, how many bases do we have? How many bases do we have here? That was E, so I'm going to call this F and G. How many bases do we have in this case? I hear 4. Does everyone agree to 4? Not how many separate terms, but how many bases do we have? Think about the question carefully. Our bases and what are what and what and what and what? What are my 4 bases? To everyone who's responding, what are my 4 bases? Chastity says we have 2 bases. Okay. What are my 4 bases? A, B, A, B. Do you see duplication there, Buhlali? How many bases do we actually have without repeating them? There, Buhlali is like, oh, there we go. We have 2 bases. Okay. Base number 1 is A. And base number 2 is B. Well done, Chastity. Okay. So now we're going to work with them as if they are 2 different bases. So I'm going to start with A's. And we are multiplying throughout. So we're still applying law number 1. Okay. We're multiplying, so we're going to add the exponents. If there is no exponent there, then what is the exponent? If there is nothing written there, then my exponent is 1. Thank you, Buhlali. It is 1. Be careful, Mine. It's not 0. It's 1 because it is there. Like if there's an A, then there's 1A. Do you see what I mean? So it's 1 plus 2 for A times B to the power of what plus what? Tell me in the chat. It's B to the power of 1 plus 3. There we go. Equals. So now finally we have A to the power of what? 3 times B to the power of what? 4. Nice. Okay, what's different with number G that we haven't dealt with so far? What's different about number G that we have not dealt with so far? Anyone see a difference between what we've done so far in number G? We have numbers, guys. Do you guys see we have numbers this time? Check. We have a 6 and we have a 2. Okay. So these bases are not necessarily different. Okay, M is its own base on its own. M is there on its own, and then we have numbers. So this goes back to a rule that we have done before, and that was SNV. Does anyone remember what SNV stands for? Maybe I should write them going down so that I can write what they stand for. My S stands for sign, and my N stands for number. And my V stands for variable. Okay, so this is where this rule is going to come in nicely for us. So first we're going to deal with the sign. They're both positive, so my answer is going to be what? A positive multiplied by a positive. That means my answer is going to be positive. So I'm just going to leave it. I'm not going to write the plus. And then we go next to our number. My number says 6 times 2. What is 6 times 2? 12. Okay, and then let's go to my variables. We have an m and an m, right? So m to the power of 2 times m to the power of 3. So we're going to add the exponents. So then my final answer is 12m to the power of 5. There we go, guys. So this is where this rule comes in really nicely. Just make sure that we deal with everything that we are meant to deal with. We don't leave anything out. So you start with the sign. Is it a positive and a positive, or negative and a positive, or negative and a negative? And then you move on to the numbers and you multiply them, and then you move on to the variables. So this rule is really nice with anything that has to do with variables, which is algebra, as well as integers and exponents, of course. Okay, let's have a quick brain break before we do the rest of these. Okay, quick brain break. Would you rather be reincarnated as an eagle or a shark? Would you rather come back as an eagle or a shark? Eagle, says Bohlale. That's interesting. Everyone who's saying shark, do you like the water? Do you like swimming? Because personally, I'm terrified of the deep ocean. Terrified of the deep ocean. So I would choose eagle any day. Wow. Nice. I would never come back as a shark, guys. I'm so terrified. Okay, the next one. Would you rather have a pet python or a pet tiger? A pet python or a pet tiger? Denomta says python, please. Do you like snakes? Oh my goodness. This makes me feel like you like snakes. A lot of people are saying pet tiger, which is great. Because the snakes thing, I don't know, eh? I don't know. Not sure about that one. I'm terrified of snakes. Same, Angel, same. Okay, the next one says, would you rather go a year without eyebrows or a year without hair on your head? No eyebrows or no hair? Many says without hair. Give me 0. Buhlale, you know how strange you look without eyebrows. Oh my goodness, guys. You look so strange without eyebrows. I would rather cut my hair. I don't want to lie. I would rather shave all of my hair off. Logan thinks it's hilarious, guys. You look swollen on the face without eyebrows. Wow. Okay, the next one says, would you rather have it rain every single day or have the weather be so cold that you can't spend 10 minutes outside? So it's either a thunderstorm or it's ice, freezing cold. Chastity says rain. Guys, am I the only one who's afraid of thunderstorms? Men is like cold because that means no school. No, that's not where I was going with this. That's definitely not where I was going with this. Wow, everyone chose rain. Well, besides Manny, who doesn't want to go to school. And the last one, would you rather eat moldy, rotten cheese or drink water from a rain puddle outside? Cheese or rain puddle? Water from a rain pot, guys. So you'd rather just, oh, this is giving me, oof. I'm surprised nobody said you can take out the mold The last time I asked this, someone was like, you can just remove the mold. I still wouldn't eat it, guys. I still wouldn't eat it. Oh my goodness. Wow. Okay, guys. I get it. I get it. Okay. Okay, let's have a nice stretch so we can continue. Okay, let's continue. Right, so we have 4 more to do. And then I'm going to come up with some interesting ones if we still have time. Now let's look at the next one. There's a lot going on here, hey? There's a lot going on. So I'm going to highlight first all the bases that we have. Tell me, what do we have? Base number 1. Someone tell me any of the bases that you can see. 2. Mene says 2. Okay, highlighter. I was on the wrong thing. I almost scratched out my 2. Say we have a 2 there, and we have a 2 over there. Okay, next. What's the next base that we have? An X, and Logan says a Y. Thank you. We have X there. We have a Y over there and over there. And finally, we have a 3 over there. Okay, let's do all of them. So now we're going to start off with the base of 2. Okay, so I have 2 of them there. They're both positive, so my answer is going to be positive. So I have a 2 to the power of 4 plus 3. I'm just going to write first what we are adding. Okay. Times 3 doesn't have a partner, so it's just 3 to the power of 5. Times x to the power of what plus what? X to the power of what plus what? One plus 5. Wonderful. Times y to the power of what plus what? 5 plus 2. Okay, equals. Right, so then we have 2 to the power of what? If we simplify that, then it gives us 2 to the power of 7 times 3 to the power of 5 times x to the power of 6 and y to the power of 7. Okay, if I were your teacher, I would prefer that you simplify this guy because they are numbers and you can actually simplify it. Okay, so what's 2 to the power of 7? Just 2 to the power of 7. If you calculate that, how much does that give you? 128 times 3 to the power of 5. 3 to the power of 5 gives you 243. Okay, and then I'm going to write times x to the power of 6 times y to the power of 7. What's 128 times 243? We are over here. 128 times 243. It is 31,104 x6 y7. Nice. All right, let's do the next one. A lot going on over here as well. Let's highlight my bases. Base number 1 is what? Base number 1 is 3. Okay, we have a 3 there. Oh, is it 3? Is 3 a common base? I almost fell into that trap, guys. Look carefully. X is a base. Why is 3 not a base? Let's look at the 3s. What's going on with 3s? What's wrong with the 3s, guys? Why can they not qualify as a common base? Does anyone have an idea why? No? Anyone? It's fine. Guys, one of them is positive and one of them is negative. Is positive the same as negative? Thank you. Positive and negative are not the same. And then the other base we have is a y. So we're going to have to go back to our SNV. Okay, so let's start with symbol. I'm going to start with the numbers. A positive and a negative give me a what? My answer is going to be negative. And what's 3 times 3? 9. Okay, now I'm moving on to the x's. Okay, what am I adding with my x's? It's x to the power of what plus what plus what? Let's see. Negative 2 plus 3. Is that all? Is that all for my x's? Nice, Bukhali. Plus a negative 3. Okay, and then y is on its own. Now, Bukhali has already told us, but tell me what happens with this plus minus over here. It becomes a what? A negative. So it's negative 9 to the power of x. Nope, negative 9 times, excuse me, x to the power of negative 2 plus 3 minus 3 y equals. Okay, negative 9 doesn't change, right? What's negative 2 plus 3 minus 3? Negative 2 plus 3 minus 3. There we go. X to the power of negative 2 times just y. And that's my final answer because we do not have values for those. Okay. Next I have negative 4x cubed y to the power of 9 times negative 5xy squared. Okay, symbols, negative times a negative. So my answer is going to be positive. What's negative 4 times negative? What's 4 times 5? Excuse me, we already dealt with the negatives and positive. What's 4 times 5? We have a 20. And now let's go to the x's. X to the power of what plus what? X to the power of 3 plus 1. And y to the power of what plus what? 9 plus 2. So then my final answer will be 20 times x to the power of 4 times y to the power of 11. Okay, let's do this one and then I'll have a nice check-in and I'll allow you guys to screenshot. Here we have the same base, so it's pretty easy. We have a to the power of 2x plus 3x plus 1. So my final answer will be a to the power of what? Let's see. Let's see if we remember this one. There we go. 5x plus 1. Okay, let's have a quick screenshot. I'm going to zoom out a little bit. Okay, I said a little bit and then I overdid it. There we go, screenshotters. Go ahead, thumbs up, thumbs down on what we have done. Do we understand the first law of exponents? Do we understand the first law of exponents? I only have 2 thumbs up. There we go. Okay. Okay, wonderful. You guys went through this much quicker than I expected. So I am gonna spice life up a little bit. Okay. I'm gonna spice our lives up a little bit because I like it. I like doing that. I even lost count of where we were. Okay, that was G. This is H. That's I. We have J and K. Okay, let me make a question called L. So I'm going to say negative 2x squared y negative 4. Y negative 9 times 3x to the power of 9. Okay, how many bases do we see here? How many bases do we see here? Chantal says 4. Everyone else? Okay. All right, let's start with our numbers, okay? We have numbers over here. We're actually supposed to start with symbols. I'm messing up my own rule. Symbols, numbers, variables. We're starting with symbols first. Okay, so we have a negative and a negative and a negative and a positive. There's nothing there, so that's a positive, right? So what's a negative times a negative? It's a positive times another negative. It's a negative times a positive. Still a negative. Thanks, Logan. Thanks, guys. So we're a negative. Now let's go to numbers, okay? 2 times 3. How much is 2 times 3? Times 3. 18. Wonderful. Now let's start with my x's. So it's going to be x to the power of what plus what plus what? So it's x to the power of what plus what plus what? Let's check our x's carefully. Butlale says 2 plus 1 minus 3. Is there anyone else who has an opinion on that? 2 plus 1 plus 3. Oh, Logan has another one there for us. 2 plus 1 plus minus 3 plus 9. Everyone else, are we with me still? So it is 2 for the first one, plus 1 over there, plus a negative 3, plus a 9. All right, there we go. Next, we have y's. So y to the power of what plus what? Y, give me the exponents that are added for y. Let's see. Negative 4 plus 7 minus 9, says Butlali. So we have a negative 4 plus 7 plus a negative 9. Okay. Now I'm going to simplify those plus minuses. A positive and a negative gives you what? So it's going to be x to the power of 2 plus 1. A positive and a negative give you a negative 9. Nope, negative 3. Excuse me, a negative 3 plus 9. And it is y to the power of negative 4 plus 7 minus 9. So my final answer is negative 18 times x to the power of 0. Let's see. 2 plus 1 is 3. Minus 3 is 0. Plus 9 is 9. And y to the power of... Thanks, Logan. Good. Buhlale, you missed the 9. Close one there. Y to the power of negative 4 plus 7 minus 9 gives us what? Mina says negative 4. Buhlale says negative 13. There's a lot going on. Ofani says negative 6. Yo, we have so many different answers. Yolanda seems to agree, and so does Logan, and so does Minnie. Okay, negative 4 plus 7 is? Negative 4 plus 7. 3 and minus 9. Negative 6. All right, guys. I'm going to go ahead and end our lesson here. Final thumbs up, thumbs down. If you have a question, now is the time to ask.